Alright, so the ones that are most missed, let's go to number 10. The outlier that people put is a lot of people put B. But the answer is actually D for number 10. So let's figure out where and why. Okay? So when I'm given something that looks like a fraction, and if you see the word if and a comma, the information in between, you must first solve most likely for that variable that you're looking for. And yes, that's exactly what we want to do because we want to ultimately solve for t. So I have t plus 5 over t minus 5 is equal to 10. Something that helps a lot of people right here, right now, because they struggle with fractions, is to think of this like a proportion. If I put 10 over 1, and I think of it like a proportion, I'm going to cross multiply these, and I'm going to cross multiply these, and now I no longer have a fraction per se. So I'll have t plus 5 times 1 remains, bless you, as t plus 5. And then t minus 5 with parentheses, that's very, very important, times 10 is going to show that this 10 is going to distribute onto both of these terms. So I will get 10t minus 50 is equal to t plus 5. Now it's a matter of just combining all my t's together. Okay? So looking at this, I like to keep my coefficients positive. So right now I have 10t and 1t. So instead of subtracting the 10 over to the left side, I will actually keep it there, and I will subtract this t over so that I have 9 t's left on the right side. You with me? And now I'm going to do what with that 50 over there, that negative 50? I'm going to add it to both sides. Yeah. So I'll get 55 is equal to 9t. And last but not least, I will divide by 9, which cancels to a form of 1, and you get 55 over 9. Okay? Any questions on that one before I move on?
Hold on, can I get a second to write all that down?
Oh, and that's another reason why I record, is because I want you to, at home, if you need to catch up, because I want to do as many problems with you as I can, I'd rather you copy that at home, okay? So just, I will share this video with you guys to remind, and you can copy it later if you need to. Okay. All right, so let's go to the second most missed problem, which is number 13. So number 13, actually that's 12. Number 13 is right here. So I have two functions, okay? And some of you might be kind of working with this kind of information right now in your Algebra 2 class. Some of you have already taken Algebra 2 and you've already seen this, no worries. Let me go ahead and highlight what I'm seeing right now with f of x. F of x is this positive, means that it looks up, 8 squared minus 2. G of x is this negative, so it means it faces down, 8x squared plus 2. Okay? And they're graphed in this xy plane above, and the graphs of f and g intersect at the points k0, so let me highlight that real quick, and negative k0. Oops, let's do that with a different color. And what is the value of k? So all I need to do is find out when does this blue graph touch the orange graph. Otherwise, when is this blue graph equal to the orange graph? Okay, that's when they intersect. So now I'm going to solve for x. Okay, now look again, like I showed you from before. I always like to keep my x's positive as much as I can because it reduces the amount of errors that I can make throughout processes. So I'm actually going to add 8x squared to the left side to get what?
16
Nice, 16x squared. And if you need to write this minus 2 and write each step at a time, I'm okay with that. There's nothing wrong with that. Then I'm going to do what to both sides? Add 2. So I get 16x squared is equal to 4. Because I added 2 to both sides, and I'm trying to get rid of everything and just get x all by itself. What am I going to do next? Perfect, divide by 16. So I get x squared is now equal to 4 over 16 reduces to 1/4. And the very, very last thing that I will do is what? Take the square root. So the square root of the left side and the square root of the right side, I get x is equal to the square root of 1 over 4. Some of you have been exposed to this. Some of you may not have been exposed to this recently. But this right here is the same as if I had the square root of 1 over the square root of 4. What's the square root of what? 1. What's the square root of 4? 2. So my answer is 1/2. The answer is B. Okay? All right, so now according... Yeah, go ahead.
I just need a minute because my brain needs a second to process that.
Okay, no worries. Before I move on to the next one, are there any questions from how we set it up or why we set them equal to each other at the beginning? No questions? Okay, so one more thing before we move on, because you'll see this sometimes. Can someone tell me what the answer to that is? 9. So here's the thing that they will try to trick you with sometimes. It's actually 2 answers. X is equal to 9 will work, because if I plug 9 in, what's 9 squared? 81. Because it's the same as 9 times 9. But there's another one that works. What is it?
X equals square root of 81?
Not square, well, it is square root of 81, but it's a negative 9. So guys, when you take the square root of something over here, it's going to be a plus or minus answer. This one didn't need it, okay? But sometimes it does based off the way that they're asking you these questions. Because what's negative 9 squared? Well, it's negative 9 times negative 9. What's 9 times 9? 81. What's a negative times a negative? Positive. That's how you get back to positive 81. Okay? All right. So let's move on to the one that was missed the most next.
Sir, how long does this class go on for? Does it
Until
go on
7. Until 7. So we have 25 more minutes.
Can I message
Yes.
my dad
Yeah, if you-
at 50 so he'll be
Yeah.
here?
Yeah, that's fine.
All
So
right,
let's
thank
move
you.
on. You're welcome. Let's move on to number 16. So 16 is saying, what is the maximum height in inches of a shampoo bottle that can stand upright on the middle shelf? Okay, so this is definitely geometry. Okay, and if you need to write that down for notes, that's fine. This is geometry and it's ratios, and we'll definitely be doing a lot of this in Delta Math for sure, because a lot of people are out of practice with ratios and whatnot. So Jim has a triangular shelf that attaches to his shower head, and the total height of this system, or this shelf, is 18. So all of this right here is 18 inches tall. And there are 3 parallel shelves as shown. Okay, so the 3 parallel shelves are here, here, and here. What is the maximum height in inches of this shampoo bottle? We're basically trying to find what is the maximum height that this can be right here. Okay? If I were to create a ratio of some kind, would you agree that this is the entire diagonal that is for the entire height of 18? Would you agree? So basically what I'm doing is I'm looking at this big triangle where this side right here is 18. What would the hypotenuse be? 6x, perfect. Because we have 3x, we have 2x, and we have x. And if I add them all up together, I would get 6x. Do y'all see how we did that?
Yes.
Okay, so now, looking at this, we have 5x would be basically showing what is this height from here to here. Do you agree? And then the last one we could do a smaller one that had 2x that showed just the height of that one right there. And what we're about to do is create proportions and ratios on everything. Okay? So if I did a proportion like 6x is to 2x, what I'm doing right now is I'm comparing the big one to the smallest one is the same as the big height to the smallest height. But here's the thing, I don't know this height. You with me? And I don't even know this height. So what I have to do is kind of see that this is basically 3 parts of what the total is. So it's like saying 6x is kind of equivalent to like this 18 piece. Okay? So we're going to say 6x is to 3x. Do you see how I'm doing this? Is to what?
Sir, the shampoo is on the 3x part.
Is on the 3x part, yeah. And this is what we're looking for. This is almost like our question mark, right? So what could we say? It's
So
9.
you have, shouldn't it? Oh yeah, I see now. Sorry.
Yeah. So it'll be 9, right? Because
Yeah.
3x is half of 6x.
I knew it was going to be 9. I just didn't have enough time to get to this part.
No worries. No.
So I had like 1 minute left on the timer. I was like, well, I'm not going to get anything done,
No.
so might as well just stop here.
It's okay. It's okay. So what I wanted to show you is this ratio right here. This ratio of 6x over 2x, sorry, over 3x, this will reduce to 1/2. So if I still have that 8 and the unknown, it's just cross multiply, divide, and so on and so forth, right? As far as like showing that it's going to be 1/2 of it, so it's 1/2 of 18, which would give you the 9. Does that make sense? Okay. Let's move on to the next one that was most missed. Is number 20. Because of the sake of that problem and the level of difficulty, we can come back to something like that. We just need more practice and exposure to other things first. So I'm not going to quite show that yet. We need to read more from our book first. 17 or 14 is what I want to show. Let's show 14 first. Okay, 17 and 14. And most likely we will do probably like 3 to 4 more, and then we will call it a day for today. Okay, so number 14. If the expression above is written in the form of a plus bi with no fractions, nothing in the denominator, where a and b are real numbers, what is the value of a? So in case you haven't recognized this before, y equals mx plus b is the same as b plus mx. And this piece right here is a lot like this right here. Okay? And what we're trying to do is we're trying to see these forms, how can we simplify to an a plus bi representation? Let me see where you're at with math right now. If I had this, what would your teacher most likely tell you to do? If you have an answer that was like 3 over root 2, what would your teacher would accept an, like this has nothing to do with the numbers that we're using. I'm just trying to see, what do you know to do with this in the denominator?
Well,
Find the root, right?
Square root over 2 over square root.
Perfect. So we are going to rationalize the denominator by multiplying it by a form of 1. If you don't know that, please write that in your notes. This is to rationalize this denominator, means to get rid of the denominator's square root. Okay? So looking at this, square root of 2 times the square root of 2
would be 2.
would be 2. Because it's the same as the square root of 4. We get this 4 from multiplying those two. Okay? So just so you know, in case you don't know that, if I had the square root of a times the square root of b, it's the same as the square root of whatever a times b equals. Okay, and that's what we just did here. So the denominator would be 2, and the numerator would be 3 root 2 over 2. Okay? That's what we're doing here, but it's a different format. Okay? My goal is to cancel that piece. I don't want anything in the denominator because I need something that looks like, whoops.
I don't even know what that I is. Is it?
I'll get to it in just a bit. So a plus bi.
Because if I enter that into a calculator, I would get a NaN or not a number.
But this is a non-calculator portion, so just hold up just a bit, okay? So a plus bi over 1 is what I want to get. A plus bi over 1. So I need to find a way to get this canceled. Okay? And we're going to do it very, very close to what we just did. We're going to multiply by a form of 1 that will help me cancel this. Okay? And instead of a subtraction, we're going to put addition. So whatever sign that you see right here, you're going to put the opposite sign right there. Okay? Because ultimately we are going to multiply these two denominator pieces. And we're going to get 3 minus 2i times 3 plus 2i. Again, all we're doing is rationalizing the denominator a little bit. So here, we're going to FOIL. What do I get when I multiply those first two? 9. So the F, or FOIL, the outside pieces are these two right here. Whoops. So the outside piece for the first one is 3. The outside piece for the second one is 2i. When I multiply them, I'll get what? 6i. How about the inside pieces? What would I get? Come on, guys. I'm multiplying these.
That would be 6i, right?
A negative 6i. So
Negative 6i.
negative 6i. And then the last one, a negative 2i and a positive 2i multiplied together will give me what? A negative 4i, right? Negative 4i. And someone said it, negative 4i squared. So this note they like to give to you on the test a lot. They say that I is the square root of negative 1. That means I squared is what? Not 1, but
Negative 1.
negative 1. Because look, if I have square root of negative 1, whoops, and if I were to, look at this, square this, what happens to the squared and the square root? They cancel. And all you're left with is what's underneath that square root, which is a negative 1. So now where I see this I squared, I'm going to put a negative 1. So it'll be 9 minus 4 times negative 1, which is 9 plus 4. Can someone tell me what happened to these that I didn't end up writing them again? Yeah, they canceled out to what number?
0.
0. Nice. So adding and subtraction will cancel to 0. Multiplication will cancel to 1. Look at this. 1/2 times 2 over 1 will cancel to what?
1.
1. Okay? So multiplication cancels to a form of 1. Adding and subtracting cancel to a form of 0. That's important. Alright, so all that work that I did was just so that I could say this denominator now is 13. I still have to multiply this numerator. Okay, here we go. We're going to do this off to the side. So we'll say 8 minus I, 3 plus 2I, We're going to FOIL method this. What's the first 2 multiply out to? 24. Nice. What is the outside piece multiplied to? 16i. Good. What's the inside piece? Negative 3i. What is that? So let me fix that. 16i, negative 3i. And what is the last one?
2i squared.
Yeah, negative 2i squared. Okay, so now all of this together, we know I squared is negative 1. So what this is negative 2 times negative 1.
So that's plus 2.
Plus 2. We still have the 16. We still have this 3. We will combine these 2 together to get 26. And then I have how many i's left over? 13. So plus 13i. So my answer, guys, right now is 26 plus 13i all over 13. And it's really, really close. Right now, it's really, really close to this a plus bi. Now, I know you guys are copying this down, and I appreciate you taking great notes. But if by some chance, at some point in time, I'm going too fast, I would rather you not copy, and I would rather you listen and just watch. Because then you could copy later and concentrate on questions. Your job for the next 5 weeks is to concentrate on really good questions and timing of them, okay? All right, so with this, how can I get this to look like a plus bi? I could multiply it by 13, but here's the thing. I can't, it's not an equation per se. I see what you're saying. If it was equal to something, then I would multiply by 13. But it's not equal to something right now. But thank you. That was a good suggestion. For other things, yes, for sure we would do that. What could I do? I'm going to break this up into 2 fractions. Do you see what I did? 1/2 plus 4/2 is the same as 1 plus 4/2. It's easy to go from I have a common denominator to here, but a lot of people sometimes struggle to go backwards. So what we just did is we went backwards and created 2 fractions with the same denominator. Are you with me?
Yes, sir.
Okay, so what does 26 over 3 become? 2. What does 13 over 13 become?
1.
Just 1y, right? So all of that will simplify to 2 plus I. So what's my answer? 2. A is the answer. It is a hefty problem. And Grant, when they pass 10, number 10, anything past 10, it's like, all right, we're here to play. It's time to make sure we know what we're doing. Okay? So, and yes, this is knowledge. This is not one that you can do that you can kind of read through, pieces and trial and error and plug and chug. This is not one of those problems. You've got to know that content for sure. All right, so let's go to number 17. And I think 17, looking at the time right now, might be our last problem that we do. We might be able to do one more. 7 after this. All right, so 17. All right, so what we're going to do is we're going to concentrate on what pieces did they give us and what are we trying to find. So the sine, the cosine, immediately we should start thinking about something we learned back in geometry, SOHCAHTOA. Okay, we learned SOHCAHTOA, but do we know when to use it? Okay, we only use it with right triangles. Okay, if you don't have a right triangle, don't use SOHCAHTOA. We do have a right triangle, so we know we can use it. Okay, so here we go. Another way people write SOHCAHTOA is they write it like this. And the reason why they write it like this is because they want you to remember the sine of something is the same as the opposite over the hypotenuse. The cosine of something is the same as the adjacent over the hypotenuse. And the tangent of something is the same as the opposite over the adjacent. Okay, so they gave us the sine of x is equal to 0.6. So immediately what you should be thinking is the sine, not sin. Okay, so this is not sin or tan, there's no or cos. So the sine of something is the opposite over the hypotenuse. Do you see an opposite over hypotenuse right there? It doesn't look like, right? It looks like if it was, it kind of looks like it would be 0.6 over 1. But that's not it. So way back when, maybe in what, I think 4th, maybe 5th grade, we did a lot of conversions between decimals, fractions, and percentages. And this is why we did it, because 6.6 is the same as, remember you learned this, my son's in 4th grade, my youngest son right now, and he's learning it. And it's, what would we put? 6 what? Tenths. Remember that? And if it was like 0.63, we would say it's 63 what? Hundredths. Remember that? So 6/10 is the same as that. So looking at sine of x, we now have an opposite over hypotenuse. Okay, so let's kind of visualize we're putting our body where x is at. So imagine that you are standing where x is at. Opposite from you, which is way over here on the opposite side, is 6. The hypotenuse, which is always across the 90-degree angle, is 10. How could we solve? Well, before I tell you what we're going to solve for, the question's asking what's the cosine of y? You with me? So cosine is what's the adjacent over the hypotenuse if you put your body where y is at. Okay? Look up here. What number, if you're standing right here, because you're y, and you're taking the cosine of y, which is the adjacent over the hypotenuse, what number is a? What's the number that's adjacent?
6.
6. Yep, this one right here. The adjacent is right here. Again, we're talking about from y. What's the hypotenuse? Still 10. So you never even had to use Pythagorean theorem to solve for this missing piece. So the answer is still 6 over 10. You with me?
Yeah.
Because if you don't know this already, and you can put this in your notes, I think it's something worthwhile. On a triangle, let's say we have angle A and angle B. The cosine of A is the same as the what?
Sine of B.
Sine of B. Just like the cosine of B is the same as what?
Sine of A.
The sine of A.
What would that make the
Tangent?
T? The tangent?
There's no relation with the tangent. That you have to actually solve those out. This is
Okay.
just because sine and cosine are a part of the acute angles that are forming that other 90. Okay. Questions? So let's say that you accidentally went all the way to, maybe we need this length right here, and we'll call it x. Okay? So we know that we had, this triangle of 10, 6, and x. And if I told you, now we've discovered that we don't need to know this x. But if it was a problem that the pieces that they gave us, we were looking for x, what's the easiest way to solve for x?
Pythagorean theorem.
Pythagorean theorem. Here we go.
A plus A squared plus B squared equals C squared.
Yes. So we have A and B are the legs, and C is the hypotenuse. It doesn't matter what order you put the other ones, as long as you have the hypotenuse C all by itself. Okay? So we'll say x squared plus 6 squared is 10 squared.
That is x squared plus 36 equals 100.
Yep. And then subtracting 36, we get
That would
60.
be 8 squared.
64, yep. Just be a little patient, please. X squared will be 64, and sure enough, when we take the square root, we get 8. 8, right? So this is a 6, 8, 10, which is otherwise a 3, 4, 5. So 3, 4, 5 Pythagorean triple you will see a lot. Okay? Let's say it wasn't 3, 4, 5. It wasn't 6, 8, 10. What's the next one up that we could create as a Pythagorean triple if we're talking about
It's 7 o'clock.
9, 12, 15. Yep, 9, 12, 15, because we would multiply everything by 3. Cool. That's all I have for today, guys. Please make sure that